All right, everyone, welcome back to Mastery Project, the final one. So the first question is asking us which point will have the greatest amount of, let's see, rank the three locations according to the amount of tension that the cable would support. All right, so the basic thing that we have to break this down is the torque. They all have the same amount of torque needed to rotate. That would be the torque of gravity. So if we were to place one down here, that would mean that the tension would be the highest because the radius would be the shortest. This one, it'd be at the at the same point in which the torque of gravity is exerted. But if we so this one would be better than that one. But if we look at this one, the bigger radius means that there would have to be more force added on. So it would have to be C. So we go C. All right, so now we go on to question B. The student is hanging on the table. The cable breaks. It goes counterclockwise. Indicate the acceleration, which acceleration would be the fastest. All right, so the acceleration would be the fastest at, wait. So the greatest acceleration would be at T1, followed by T2 and T3, because we know this because as theta grows, so will the angular acceleration grow. On to number C. Now number C is asking us to, number 2A, C is asking us to show that angular acceleration is equal to 3g sine theta over 2L. And the moment of inertia we're given of the disk is I is equal to 1/3 ml squared. All right. So we can start off with our basic force statements. Li is equal to Lf. From here we know that L is equal to 1/3 the moment of inertia. Mr squared, angular acceleration, so A over R. Cancel this out. The sum of the torques, this can also be represented as sum of torques. Torques is equal to 1/3 Mr squared. We can simplify this to L, so A, L. Simplify this forward because we know that the only torque affecting this would be the torque of gravity. So we can replace the sum of the torques as mg sine theta, which is equal to 1/3 ml squared A over L. Simplify this forward, mg sine theta is equal to 1/3 ml A. 3 mg sine theta is equal to ml A. And simplify it even further, we get the final thing, which would be 3 sine theta over L is equal to A. All right, so that is number 2I. So the final question asks us to basically write a graph in which we have angular velocity and theta and match the graphs appropriately. 1 second while I finish this up. All right, so now we're given a chart in which we find a relationship between, excuse me, we find a relationship between omega and theta. So as theta approaches 90, it reaches angular speed of 0. So from here, we are given 4 different equations and we're trying to derive which equation best fits the graph. And from here, two things that I did. Well, first of all, I looked at it from a graph perspective, and then I did free body. So we know what's the most basic math thing we know. We know that when cosine is 90 degrees, it equals 0. So from there, all I did was I crossed out the ones with sine. That's how we got rid of the sine ones. And then for the other part, I had to do some thinking about what we did. So I went back to the free body diagram. We did a free body diagram of what exactly is happening. What are the variables that are happening? Currently, the mass is experiencing a downwards force of gravity. That's the only thing affecting it, not the radius. It's the gravity. So if we break it down into vectors, it would be cos. It would have to be cos. It can't be sine because it's not fully rotating the other way, it's just going down. And so that's why I put the first one as the answer. That should finish all. Thank you for listening.